Okay, this is the last part of the material testing. I'm going to talk about the extra topic on the concrete product. The students supposed to know about this kind of product because nowadays we use the concrete product a lot in our construction. I should start by what's so-called the concrete masonry unit or the CMU for short. These concrete masonry units have been used a lot as the load-bearing wall in house in Western country. This load-bearing wall is used to replace the beam and the column. It's going to take the loading transferring from the floor and directly to this wall. This wall has a large strength and stiffness, and most of the time this wall were reinforced by the grout, which is a special kind of concrete, and the steel reinforcement. And as you may see, the slab transfer the load directly to this kind of wall. The load-bearing wall usually can be designed as a form of a column. The concrete masonry unit usually produced by mix the Portland cement type 1 with the fine crush aggregate. The ratio of the Portland cement and the crush aggregate can be vary from 1/4 to 1/8, and then it's going to mix with a proper amount of water, and then they are going to produce by using the Cmu Production Machine. And in Thailand, you can see a lot of this kind of brick with 70 millimeter, or you also may see some have the 90 millimeter, but a few of them have the thickness of 14 millimeter and the 19 millimeter. The block, the CMU with 14 centimeter thick and the 19 centimeter thick are usually used as the load bearing wall, because this unit going to have very thick, going to produce very thick wall, and the size of the thickness you can put the slab, precast slab onto this wall easily. Okay, and in Thailand there is the TIS 57 as the standard for the load bearing CMU, and we also have the TIS 58 that is for the non-load bearing CMU. And as I mentioned, the CMU can have the thickness between 70 millimeter to 190 millimeter. And the picture here show you the Cmu Production Factory. This is the Cmu Production Machine. You feel the mix of the Portland cement type 1 and the crush lock into this portion, and then this machine will produce the CMU unit out of the machine. And then this show you many kind of shape of the concrete block produced in the United States of America. You can see they have many kind of size and shapes. And typically in Thailand, we have the CMU production with the one maybe have 70 millimeter, and as I mentioned, some may also have 14 millimeter and 19 millimeter. And the load bearing CMU going to be the one that I'm going to focus today, because I believe in the near coming future we may use load bearing CMU more. The picture shown here is the load bearing CMU wall. is the construct of the reinforced, what's so called reinforced CMU wall. Okay, this wall reinforced by the steel, as you may see here, and also filled over here in with what's so called the grout, Grout. Grout is a mixture between the Portland cement type 1 also with the fine aggregate. Okay, aggregate usually is the crush rock and the sand. It's going to have smaller coarse aggregate compared to the concrete. And the load-bearing CMU usually has the thickness between 140 to 190 millimeter, and it's going to have high compressive strength. Okay, and it's also going to be severe weathering grade. Okay, based upon this, uh, this load-bearing CMU can be used in the construction of the load-bearing wall, as I mentioned, and also the retaining wall. Retaining wall is a kind of wall that uh, resists the pressure from the soil. That means what? That means this kind of load-bearing wall will contact with the soil and water. So the grade of the CMU unit that we are going to use is going to be the severe weather grade. The wall is typically reinforced by steel and grouted in the whole of the CMU, as I did mention before. And this is a typical detail of the construction of this kind of load bearing. Okay, and then you can see there is a lot of detail of this, and you can see at the top and the middle of this wall also reinforced by a kind of steel beam. Okay, and the classification of the load-bearing CMU, according to the TIS 57, we classify them to two main types. One is the load-bearing with control moisture content, and another one is without control the moisture content. The control moisture content going to be a better load-bearing CMU, and then it's classified into cash core -1, cash core -1, and cash core -1, both of them. And in the big picture, the cash core -1 and cash core -2 are for the exterior wall, both below and above the ground level. That means what? This class of CMU can tolerate to severe weathering. Okay, weathering, and then not require the surface protection. It's going to be built with the high quality. And the second case is the cat core -1 and core -2 can be used for exterior wall, both below and above the ground level. However, for this class, it's required to protect the surface. Okay, we need to use a kind of waterproofing material to paint on the surface of this wall. And the last one is the class core -1 and core -2. This usually used for the interior and the exterior wall above ground level. I should focus. It's going to be above ground level. This is the lowest class of the CMU unit, and it also requires the surface protection to resist for the water, to resist for the sunlight. And this table show you the specification specified in the TAS 57 and TAS 58 when you buy this kind of CMU, both the load bearing and non-load bearing. You got to check what you got to check the water absorption. You know that the CMU with high water absorption going to have a low strength, because with high water absorption it means the CMU going to have a lot of void inside it, and then when it have a lot of void, the unit weight of the CMU going to be a low one. Okay, that means the CMU with lower unit weight, the CMU with high water absorption, that's kind of CMU going to be the low grade one. And then we check the ultimate compressive stress, and the stress can be computed for the average total area and also compute from the average net area. You got to check all of them. Okay, and as you may see, the high quality CMU require you to check everything. Basis on this, it means what the CMU supposed to have the strength, okay, as large as this one supposed to be unit of, I think supposed to be in the KSC, right? Okay, on site is Newton per square meter. Not correct. I think it's supposed to be Newton per square millimeter. That is going to be megapascal. It's about 6.9 megapascal or about 70 KSC. Okay, that's correct, because we have the sigma sub y, that is about 250 megapascal, which is equivalent to about 2400 KSC. So it's going to be 10 times, about 10 times different. So this is supposed to be Newton per millimeter square in the unit of megapascal. Okay, and then you can see for the test, you got to test 5 units and do the average, and each unit must pass this one. Okay, and then for the compute by the net area, if you use the net area, by the net area, the strength of this is going to be 140 KSC, which is very close to the typical concrete that's we mix by hand. Okay, and the H unit also have the 110 KSC or 10.8 megapascal. And then when you test everything must pass at the same time. And come to the second one for the non-load bearing CMU. This is using for the general purpose in the interior area. Usually we use it to divide the room. It's going to be the wall that's going to divide the room. And the dimension, the width and the length are equal to the load bearing CMU. However, most of the thickness going to be smaller. Okay, that is the picture of the typical non-load bearing CMU. And then according to the TAS 58, the TAS 58 classified the non-load bearing CMU into 2 types. Again, one is the non-load bearing with the controlled moisture content. Another one is based on without control moisture content. The one that's control moisture content going to be a better quality. When you buy the non-load bearing CMU, you got to check the allowable dimension. Okay, the error cannot be as much as specified here. The CMU shell must be at least 12 millimeter thick. I mean the thickness of the wall here. When you buy it, you got to check. Okay, and then the width, the length and the thickness must not different from the specification. Okay, cannot. It's going to be in the error of only 3 millimeter. And then for the compressive stress of the non-load bearing CMU, the value is going to be the 5 unit. The average must be larger than this one, 25 KSC or 2.5 megapascal. And you can compare from the previous one. It's going to be a lot lower coming into this table. Okay, the lowest case of the load bearing going to have the strength of 50 KSC, and for this one is only a half of that. And for each unit, when you test it, each unit must be larger than 20 KSC. Okay, you may see the non-load bearing CMU have the strength less than the load bearing by a half the lower case of the load bearing. And then the advantage and disadvantage of using CMU in the construction is going to be the same as the big advantage. One, it has a high compressive strength and the CMU is very durable. This kind of CMU unit also be the foul-proofing material. So it's going to be to be good to prevent the noise, and it have fire resistant, so they require no fire proofing material to paint on it, and the temperature proofing material also. And then it's very aesthetic since it can be constructed in various size and shape, and it's cheap and low maintenance cost and compared to the steel, and it's going to be environmental friendly when compared to concrete and steel. There is two disadvantages. One, they need more detail as I show you from the some previous slide. When you decide it, you're going to put a lot of detail in the construction. It's going to be much more than the steel. Okay, and it's also require very high skill labor in the construction of this CMU structure. In the US, the mason, that is the one who produce the masonry. This is a very high salary occupation. Okay, but it's going to require a lot of skill to construct the CMU structure, and also the mason must go uh, to the meeting to learn a new technique, and they require the mason to have the certificate. In Thailand, we don't have that. Okay, but anyway, the mason, the very high skill mason in Thailand also 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 get very good salary. So I have a friend told me they 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 charge us per meter of of their wall of their floor when they construct this kind of structure. And this last part of the CMU, I show you the research study of one of your senior. Okay, they work to find the optimum mix proportion of the CMU production. Actually, one of our student has the CMU production company in Nakhon Ratchasima, and he kind of curious to improve the CMU in his father factory. So he coming to ask me for this kind of study. So I went to the factory, and we we changing the proportion of the CMU by changing for 1/6, 1/7, 1/8, 1/9, 1/10, and 1/11. I supposed to note, I should note that the 1/9 is the one that the company is using, and he kind of curious to improve this production. So we did a lot of tests in the lab, as I show you in this picture. Okay, some of his friends join his project and do the compression test of the CMU unit, and then we compare them with the ultimate compressive stress, with the density, with the water absorption, and by compare them we found that if we change the proportion to 1/7, okay, we found that when we compare with the normal production of 1/9, the compressive strength getting 30% better. Okay, and then the production costs increased by 8%. So you can see this is going to be the trade-off. The quality of the CMU going to be higher, but the price may be also higher, but the quality of the compressive strength of the CMU get higher as much as 30%. but the price higher is only 8%. So the weight ratio is going to be 3.75, and this is going to be the optimum point. By studying this group of students graduate, and I also published this paper at the National Convention for Civil Engineer, and also, staying or not, Pawat also requests this report and the paper, and then he showed to the Australian government to fulfill his keen card application. It's very strange. This is my new knowledge. You can use the research to fulfill the green card requirement of Australia. Okay, we come to the precast concrete slab. Okay, the precast concrete slab can be the reinforced precast concrete slab and maybe the pre-stressed precast concrete slab. The picture shown here is a kind of reinforced concrete slab. Okay, it's a special kind of it, reinforced with the three-dimensional steel here. This kind of slab used in the construction of the hotel near the Castle Stadium, the Buriram Stadium, by the Lita company. And come to the precast concrete slab. Typically, it may has the solid section or it may have the hollow section. Most of the solid section is the typical builds for the house and for the commercial building. For the hollow section, usually it's going to build for the office building, for the large building. It's built in a factory and then is transported to the construction site and use the crane to lift it and start it. And typically, like I said, it can be classified into reinforced concrete slab, precast reinforced concrete slab, and the precast pre-stressed concrete slab. This one is our focus. Okay, we use a lot of precast pre-stressed concrete slab. Typically, it's used in the construction of the floor of the building and bridge. Okay, by install it by the proper position and reinforces with the tempered steel on the top, and then you cast the concrete on the top. For example, for this one, you may have the beam on the left and oh sorry, you may look in this way. Okay, when you look in this way, that means you have the beam like this. You cut this section. Okay, you take a look here, and then there is the slab that span across your beam. And typically, the requirement of this, you're gonna have some kind of a special reinforcing steel that's going to hook them up. Okay, this one is going to be a special tight reinforcement at the end of the slab. And then you must put the temperature steel on top of this. That means you got to layering it with some kind of cubic, okay, and to spread it at a typical level. And then you pour the concrete on the top of this. What you have is going to be the concrete topping. Okay, this is going to be the concrete topping. Usually it is 5 centimeter. Okay, up to maybe like 10 centimeter, depend on what you decided. And what we have, this is going to be the temperature steel. Okay, temperature steel is just the steel that has the kind of this arrangement. Okay, and then when you put the slab onto the structure, you got to specify its direction. Sometimes you got to specify for this one. This means you put it in this direction. You're supposed to go to the academic building, maybe the academic building one. Okay, my building. You can see some of them. If we have the frame, is the beam, and it's going to have the layout some like this. You may see sometime you may have the slab in this direction, and when you come to this way, it's going to be in this way, and it's going to be like in this way. It's going to be in the perpendicular direction. For this one, to do this, it's going to make the slab arrangement to be in the opposite direction, and it's going to transfer the load effectively to this. And then come to the advantage of the precast concrete slab. You can see the advantage, very important, is no need for the form work. Okay, so it's going to reduce the construction time of building the slab, and then it's going to be the ease of construction. Okay, and again it's going to reduce construction time by cemetery works scheduling. And this is the picture show you the arrangement of the slab. Okay, when it's in place, you don't need to put a lot of reinforcement, or sorry, put a lot of formwork underneath of it. Okay, for this actually you just saw the bottom of this slab a little bit before you are pouring the topping. And also it's going to be the safer construction practice due to the reduction of the constant work. And last, it's going to reduce the air and noise pollution in the construction area. Okay, the situation of the precast concrete slab can be three types. One is going to be the solid slab. The solid slab is a slab that has the cross section like the timber plank. Okay, typically it's going to have the width of, this is standard one, 350 millimeter, and the thickness of it is going to be 50 millimeter. The length of it can be from 1 meter to 5 meter. So the largest span for this slab is going to be 5 meter. When you build the commercial building, that is the largest span. If you build a commercial building with the span of 6 meter, you cannot use the solid slab. You're gonna use the hollow core slab. We're going to talking about later. And is typically manufactured by Precast Concrete, and depend on the site, the length, okay, of the slab. You need to use 4 to 6 the Precast Concrete wire. If you have the 5 meter slab, you may use 7 Precast Concrete wire with 5 millimeter diameter. So there is the factor you got to consider, which is the span length of the slab, the load that the slab supposed to be to support it. And this is the example by putting the slab, the precast slab, into the position. Actually, in this construction, you got to put the end reinforcement in this picture also to hold the precast slab into position. Actually, there is supposed to have another way to put in this direction. Okay, so don't forget to put this one. We call this one หนวดกุ้ง in Thai word. And the second one is the hollow core slab. Hollow core slab is the slab that can be built to the structure up to 12 meter span. And this kind of slab may have the thickness from 60 millimeter to 250 millimeter. That's pretty big. Okay, you can see the picture of the hollow core slab in this picture, or you may visit the Recon Thai to check some specification for this hollow core slab. So since it can be used with the large span structure, okay, this kind of hollow core can take higher load carrying capacity compared to the solid slab, and usually used in the large structure and in the parking garage building. Okay, that means it can carry the weight of vehicle. It may or may not require the concrete topping, but most of the time you're supposed to put the concrete topping into the slab, okay, to make the surface of the slab leveling. And also sometimes you can put some protective layer on the top of the surface. When the vehicle move, the corrosion can be reduced. And the other type may have the channel section, may have the double T section, may have the tongue and groove section. We didn't have much over here in Nakhon Ratchasima and in some area. Okay, the production of this kind of slab maybe increase the moment of inertia of the section. When it's increase the moment of inertia of the section, it's going to reduce it's going to reduce the deflection. Okay, this is going to be the benefit of of precast concrete slab with the channel section, with the double T section. Okay, that's going to have higher modulus of elasticity. The table shown here is an example. Okay, you got to follow this kind of specification. Most of the time, the company manufacturing the precast slab will have this kind of table, and then you can use this table. Okay, and then you can just like, okay, nice structure gonna have like okay, 3.95 meter span. Okay, and then the 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 structure that I'm going to use going to have what the safe load that's used for 350 kilogram per meter. By doing this, I'm going to select the slab with with 7 wire, and each wire has the 4 millimeter diameter. And then there is a lot of note you're going to study about it, about the dimension of this slab. When you buy it, you got to check the dimension is correct or not. And then it's require the concrete topping and temperature steel, and you got to put the temperature steel at least this size. The ultimate compressive stress of the concrete, okay, they use this one for the construction of the slab. Okay, this is for slab manufacturing. And then this is just the specification when they cut the pre-state wire. Okay, when the strength of the concrete to be 245. This is not for us. Okay, this is just for them, for manufacturing part. But when we're going to check the first one and the second one. Okay, and there is a hollow core slab. Okay, this is for the 10 millimeter. And again, there is a lot of thing when you select the span. For example, you design the building with 5 millimeter span, and then you require 5 centimeter topping, and then that means you're going to have the section following this depend on the load that you're going to select. Okay, if the structure is going to be the commercial building, the load going to be at least 300 kilogram per square meter. You're going to select for 368. Okay, that is higher than 300 kilogram per square meter. Again, there is some requirement. Okay, you got to follow over here. That is for the construction of this hollow core, and this is for the 15 millimeter. Again, you come to the hollow core with 5 again 5 meter. 5 meter here, and then you have the 5 5 centimeter 50 millimeter topping, and then the requirement of what? Oh, this is going to be the high strength. See, this is going to be the one that can carry the load. If the load is like 1000 kilogram per square centimeter, you got to select this one, and the detail of this is going to be like show over here. Okay, and this one show you the hollow core with 20 centimeter. The carrying capacity going to be higher and higher. Okay, and you got to follow the testing when you buy the piece tested concrete slab. You got to test this first concrete slab based on the ASCI 318. Okay, based on this, you're going to compute the load that's going to use in the test. Okay, for example, you're going to estimate the cell weight of this one. Usually the slab is going to be 10 centimeter, okay, or it's going to be 0.1 meter. And then the design load is depend on the live load that you use. If it's the commercial building, it's going to be 300 kilogram per square meter. And then you have this one. This is the live load for the commercial building, and this is for 0.1 meter, which is going to be 240, because the 1 cubic meter of the concrete weight for 2,400 kilogram per cubic meter. And if you have get only 10 centimeter, the load going to be 2,400 kilogram per square meter times 0.1 meter. That is going to be 240 kilogram per, this is cubic meter, right? And then cut by this is going to be square meter. And then this is going to be the expected load that will apply to the structure. And then when you use the slab, okay, the slab going to subjected to uniformly distributed like this. And you learn before this is going to have the shear force like this, and it's going to have the maximum bending moment occur at the middle of it, and the maximum moment occur over here is going to be WL square over 8. This is going to be the maximum moment occur in the slab that you are going to construct. But in the test, the loading going to be in the form of 4-point loading. What we have going to be the form of the testing in the form like this, and the shear diagram of this one is going to be in this form, and the moment diagram going to be like this. And since this one is P over 2, and this one supposed to be P over 2, and also the length over here gonna be divided into T portion, L over 3, L over 3, and L over 3. So the moment here gonna be P over 2 times L over T is going to be PL over 6. This 810 kilonewton meter gonna equal to PL over 6, and then you can compute the load that you require, the maximum load that require you to put into the hydraulic lamp over here. That is going to be 1,620 kilogram at least. Okay, this is for the working condition. For the real one, you're supposed to time the Pmax by 2, okay, or 3. And then you also need to compute for the deflection. Most of the time during the test, we put the dial gauge over here, okay, to check for the deflection. And then the maximum load must be slowly applied to the slab with at least 4 steps. For example, we may increase by the previous computation for each step of 4 or 5 kilogram. You may put this one for 4 or 5 kilogram and push it into 4 steps and wait for 24 hours before recording the maximum deflection. And then you remove the apply load and wait for another 24 hours before leading the recovery deflection delta 2. Why? Because when you put the load into this, you got to put it for 24 hours. For what? The concrete may have the creep. Okay, the paste wire may have the relaxation. So you got to allow the time for the structure to deform to be as much as it is for 24 hours. And then for the return also, you got to wait for 24 hours to check everything to be alright. And then the delta 1 supposed to be less than this equation. Okay, or delta 1 must be also larger than this one with this one. It depends on what kind of structure you have. But for this one, the slab, if the slab have crack, it is going to be unacceptable. So it's require no crack under this kind of test. Okay, if there is no crack, just check it. The delta 1 supposed to be less than L square over 20,000 H, when H is in millimeter, when L also is in millimeter, because the delta 1 going to be in millimeter. Okay, and second, the delta 1 larger than L square over 20,000 H, but the delta 2, the return, supposed to be larger than 0.75 delta 1. What it means is it won't have the permanent set. Okay, the permanent set supposed to be very small. Okay, and then that is for the reinforced concrete slab. And for the precast concrete slab, it's said to be must be larger than 80% of delta 1. Okay, this is talking about the permanent set. If you put it to the maximum, you release the force. Okay, it's going to rebound close to its original deflection. Okay, when you piling the precast, you're going to pile properly. Usually, the alignment of this support must be in the same line. Okay, to transfer the force properly, don't make any movement in the slab. And this is the example of the detail of the construction. Okay, and you may go to the Recon Thai again to check the update of their detail of construction. And then when you design the structure, you can copy it. If you put the reinforcement into the steel, okay, you can put the detail everything like this. Okay, you can check. It's going to have the wire over here, and it have the steel stud here also. Okay, at the end of this slab, you got to put the concrete, and the concrete is supposed to fill in the core of the slab like this. Okay, and for this one for the reinforced concrete with the support, and this one is the edges RC beam. Okay, next we come to the precast reinforced concrete and precast pre-stressed concrete. The precast concrete part is popular in the building the foundation of a building, because the precast concrete pipe has high load carrying capacity. It is durable and is ease of construction. Okay, you just buy the pipe, you have the machine, you put the pipe into position, you use the machine to dive the pipe to a given position. Okay, depend on what what the design of the pipe is. Usually the pipe can have the length between 3 to 21 meter, but for 21 meter it may be hard to transport to some area. Okay, because it's really long one. It require a big semi trailer, and it have the load carrying capacity of 0.5 ton into 40 ton. That is going to be 40,000 kilogram. Okay, it can be manufactured by the reinforced concrete, or and also the precast concrete. It can be the I section. It can be the this kind of section, and it can be the rectangular section. Okay, this is the effective for the I section. Okay, because it can has what this portion is won't put much of its volume into the soil. Okay, it's going to reduce some impact during the installation. It's also reduce the disruption of the soil in this area. And there is 3 types of concrete pipe, but 2 of them are precast. It's going to be the pre-stressed concrete pipe and pre-stressed concrete span pipe. And this one, bollard pipe, is going to be a kind of cast in place. The bollard pipe is important because most of the large high-rise building in the Bangkok area, or even in the some big city, when you build the high-rise building, you gonna use the bollard pipe because high-rise building has large weight transfer to the foundation. So the pre-stressed concrete pipe and pre-stressed concrete span pipe may not have load capacity to resist that. Okay, this picture show you a few you see full of pre-stressed concrete pipe diving by the kind of the impact. Okay, diving machine. And then for the pre-stressed concrete pipe, usually is manufactured by the pre-stressed concrete in the factory and shipped to the site. As I said, it's going to dive into the soil by the impact force. Okay, using the pile hammer. This is going to be impact force. This is going to be the pile hammer. Okay, and going to impact onto the pile. And the pile usually has the I cross section. Okay, that is the popular one for the general building. Like I said, there is an effective section. The pile length must be calculated based on the foundation engineering. So you may study about this again with อาจารย์พรพจน์ or อาจารย์วิรุต or อาจารย์ลิม okay, and also kind of pile section also can be used, but they are not such popular. Okay, because they have a low loading capacity. Okay, and this is the table show you the safe load of the solid concrete pipe. Okay, you may have this kind of pipe, and you can select, for example, if you require the safe load of like typically 30 to 40 kilonewton. Okay, and it may have the length of 14 meter. Okay, you got to select the section of 26 centimeter. Okay, 0.26 by 0.26 meter, and then this is going to have the safe load here. And then if I going to use smaller length than this, okay, you got to do the computation. You got to check this is the load capacity of the pipe. You also need to check this is the load capacity of the pipe. You got to check also the load capacity of the soil. Okay, and then you compare them. You compare between them. Okay, you use which one? If the load capacity of the pipe is 30 ton and the load capacity of the soil is going to be 40 ton, so which one you can use? You can use the lower one. Okay, that is how to use the table. And then come to boarded pile. This is one of the most popular for the construction of the building, and it must be constructed on site, okay, and it's a kind of complicated process, but usually it's not that complicated, but it's going to be very dirty because of what? Because you must use you must bore the pile by the drilling machine. This is the drilling machine, and then it has the board head over here, and it's going to put into the steel casing, okay, and then it's going to dig the soil from underground and then put it up, okay, and then you got to dig it, drill it, do for some required diameter. For example, it's maybe 1 diameter like this, and for a given depth, okay, that is going to be the hole. The soil going to build like a hole like this into the soil by using this drilling machine, and then some of them going to make the end of it to be like a bell shape, okay, and then they put the steel reinforcement along this one, and most of the time this reinforcement have the spiral, okay, to tight the longitudinal reinforcement, and then they have the dummy pipe put into this, and this is going to be put to the bottom, and then during you are pouring the concrete into this, you just move this dummy pipe up. It depends on the level of the concrete that you put it in. Until you fill it in, you can take all of this out, and then you wait for like 3 days to 7 days, let the concrete to be hardened by the hydration process, and then you start to check, okay, the integrity of this boarded pile. And then when the reinforcement is stored into the desired position, you pour the ready mix concrete, okay, into it, and then the pile going to be finished for the construction, okay. You can see this machine is kind of an automatic machine. It have the clamper to put the steel casing into the position, and this boring head, okay, will dig the soil up, okay. But the boarded pile can be classified into two types. One that we're talking about is the large diameter boarded pile. This is for the small diameter boarded pile, okay. They produce this one like this. This is not require very big machine, but they require the tipper leg, okay, and some special machine to dig the soil out. This is the soil that they take it out from the hole, okay, and then as you may see, they put the reinforcement into the position, and later they will pour the concrete into this hole, okay. There is some kind of check, okay, have some kind of special skill for engineer for this kind of construction. And for the small diameter boarded pile, that is for the small building. Usually it have the diameter of 35 to 60 centimeter, and the depth of this can be 18 to 20 meter. This is going to be the first sand layer in the Bangkok area. Bangkok area have the soil level, okay, and typically it has the first sand level, and the first sand level going to have the depth between 18 to 23, and most of the time this kind of pile can be used for the building as high as like 7 to 10 story, and if it's larger than that, you got to put the pile into another level. That is going to be the second soil layer. This is going to be 18 to 23. This is about 50 meter. Okay, that is mean if you design the structure properly, you may put the pile in just the first layer of the sand. But if your building is big, okay, you got to put the bollard pile into the second layer of the sand. This is going to be the second sand layer. And for the large diameter bollard pile, there is a lot of company, and some of them are in the stock market. Okay, this is a lucrative business, and the bollard pile large size can be classified with the pile having at least 60 centimeter. Okay, and most of the time it's maybe 80 centimeter, 100 centimeter, 120, or even 150, or some of them may be as big as 200 centimeter. That is a huge one, and it can be at the length between 25 to 65 meter. Okay, it can be constructed by the wet process and the dye process. But in the Bangkok, most of the time, since the Bangkok has the clay soil, the wet process is used in that area. Okay, the wet process requires the application of the bentonite slurry in the bollard hole. That is going to stabilize the wall of the hole. Okay, to prevent it from the failure of the hole. Okay, just know the bentonite slurry, and then when you study with Ajahn Lim about the foundation, okay, you may have this into your learning again. The pile is properly to use in the construction of large structure and high-rise building. Okay, that's require large loading capacity, and again, yeah, it can be as big as 200 centimeter. So it's require a big machine like the piling crane, okay, and some special equipment, okay, and it is proper to use in the communities in the process of producing the concrete pile produce only small vibration compared to the pile hammer. When you do it, it's going to produce a lot of impact. And there is one special piece that says concrete span pile. This is a new one. The span pile is a high quality pile. Okay, it is manufactured in the factory again by spanning the concrete. Okay, and to make that concrete, there will be the dense concrete. When the concrete is dense, it's going to have higher load capacity compared to the normal produced concrete pile. And then most of these going to have this kind of section, going to have the hollow section. Hollow section is good because when you dive the pile into the soil, the pile going to replace the soil. What happens is it's going to move the soil along, allow it out. And if you have the hole in it, it's going to reduce this kind of effect. It's going to reduce the vibration from the impact. It's going to reduce the soil movement, okay, and it's going to be more effective. Because one more thing is when you produce the hollow section, the weight of this pile is going to be reduced. And again, when you put it into the truck, it's going to be easier to take it in and take it out from the truck. Okay, it has the hollow cross section as I mentioned, and reinforces a very high strength piece wire. This pile can be driven by various types of pile driving machine, and it can has the diameter between 20 centimeter to 100 centimeter, and usually it have the length of 6 to 18 meter. Okay, since the pile has the hollow section, okay, again it has the advantage such as producing less vibration during pile diving process and replacing small volume of soil and producing less side effect to the building in the surrounding area. This one I just mentioned previously. And due to the high load carrying capacity, and it can be used in the high-rise building. But the high-rise building is very high, it can be used. Okay. The last one is the concrete pipe. Non-concrete pipe, okay, used a lot in the construction of the road, and also in some building. As you may see, some building require a small size of the concrete pipe, such as 300 or 400 centimeter diameter. Okay, this is for the draining of the water in the building. But if you building a road, okay, the highway, you got to put a larger size of this kind of concrete pipe. Or if you are in the work of irrigation, okay, you also require to use this concrete pipe in your work. Okay, the concrete pipe typically used to drain water, such as the convert, okay, in the road, under the highway, or in the irrigation system. And most of the time it may have very big diameter, and most of the time is manufactured with 1 meter length for each pipe. It can be longer, but typically it's 1 meter. The production, they use a special low slump concrete with the accelerating agent mixture. Okay, and then the concrete will be compacted by using the high frequency vibrational machine to make the concrete to be dense, okay, to be compressed by the hydraulic compression machine. So the concrete that's used in this concrete pipe is a special kind of concrete with a special kind of manufacturing process. Okay, and this is one of a lucrative business, believe me. And this type of concrete pipe, the concrete pipe can be without reinforcement, and can be with the reinforcement. Okay, and sorry, there is still some type appear here, and they can be classified into two main types. One have the tongue and groove. Okay, this is going to be tongue. This is going to be groove. Okay, and then you can connect each other, or it can be bell and picot. This is a larger connection. So the production of this concrete pipe must be carefully do, because the groove and the tongue must have some special requirement. Okay, it must be perfect. If the construction manufacturing process is no good, it may produce the tongue and groove in proper shape, and bell and picot in a proper shape, and the concrete pipe may be rejected. And this is the table according to the TIS 1 to 8. The concrete pipe can be classified into 4 types, and the classification number 4 going to be the highest quality. If we come to the grade Corsolo 1, okay, you can see we're going to test it, and you can check the crack load and the maximum load. Okay, it's a crack, the load when this concrete pipe start to crack, and then it still can resist the force until it reach the maximum load, and then the load going to drop. Okay, and you can see the diameter of this pipe, okay, can be as big as 1 meter or 100 centimeter, and you can see this one going to require higher stress, okay, higher load, okay, sorry, this is the best. The Corsolo one is going to be the best pipe. And then classification Corsolo 2, the load going to be smaller, and Corsolo 3 class going to be smaller, and Corsolo 4 going to be the less. Okay, so the base concrete pipe is going to be Cosolo 1. Okay, and come to the testing. You're going to put the concrete pipe into the position like this. Okay, and then you're going to put the rubber, okay, on the top and two on the bottom, and then you're going to put the wood, okay, post on the top and on the bottom, and again on the top you're going to have the steel beam and put the load over here in order to transfer the load across this as uniform as possible. Okay, and then the rubber and the wood, okay, will support the pipe, and then you test this under the TIS 409 to the maximum compressive load and the crack load. Actually, you test for the crack load first and test it for the maximum compressive load later, and the load of the rate of loading is going to be at this one. Okay, and this is the table of the concrete pipe produced by this company. Okay, you may go website of this company and check all the requirement. And you got to construct to put the concrete pipe into the position. There is 4 types of it. Okay, and the practical way and most uses is going to be impermissible as shown in figure A. This is a typically concrete pipe construction. That means it's going to use a lot. Okay, the pipe lay to the position and cover with the compact soil. That means you dig this this hole and then you put the pipe. Okay, and then you just put the soil. Okay, allow it to a given level. The second one, you got to dig the hole for it, but you got to dig this one to keep the pipe into position. Okay, that means the soil at the bottom of the pipe is adjusted to the shape of the pipe for 0.5 B sub C. Okay, about 0.5 B sub C, half of the external diameter to make it in position. Okay, and then cover by the compact sand. Okay, that's is compact soil. This is the compact sand to the level about 50 centimeter above this. So this means it's going to cover by the compact sand. Okay, above the top surface of the pipe. And finally, putting the compact soil, and then you put the compact. Actually, this one supposed to be, let me put this one for the compact sand to be the yellow. This one going to be the compact sand. Okay, you put the compact sand over here, and then you put the author of the of the compact soil on the top of it. Different layer. It's going to use both. This one use only the compact soil. This one use the compact sand. Okay, to the 15 centimeter above the top surface, and then you put the compact soil above it. Okay, and the third one. The third one, you got to dig again this soil to put this pipe into the position of 0.6 B sub phi. And then you cover the compact sand. This one is thicker. You cover by the compact sand, the yellow one, to the level of 30 centimeter. This is going to be 30 centimeter. Before that, it's going to be only 15 centimeter. And then finally it's going to cover by the compact soil to the pavement level. However, this one, when you construct it, it must be under the supervision of the site engineer, okay, to make it. And then this one usually for important structure like in the irrigation system, or maybe some kind of the highway, okay, in the highway construction. And the last one is the concrete cradle. This is going to be very strong construction. The pipe support by a layer of concrete or the RC. That means you put it in the position as A, and then you pour the concrete, okay, into this one, okay, very close to type A, but lift it a little bit and pour the concrete to put this pipe into position, okay, on the level of the half of this. And then the sand and the soil must be compact as one of the first. That means, and then you got to put the sand, okay, you got to put the sand to the level of 30 millimeter, okay, and then above this you got to put the layer of the soil, okay, layer of the soil, okay, on the top of it, the same as this one, okay. That means it's going to require a lot of construction. This is for important drainage system, okay, in the Bangkok area or in the airport. And then there is the table that show you the diameter, okay, of the B sub C, B sub D that we previously mentioned, and you may go to the website of this company, Jalangit AR. Okay, I didn't translate it into English, just put it in Thai. Okay, that is the end of extra topic for the concrete products, and I hope you guys can study by yourself, because there is still a lot more to study. Each kind of material still have a lot of detail about it. So you got to go to the Thai Industrial Standard or the ASTM or what kind of specification your company use, and then follow that kind of instruction, okay, closely. And as an engineer, as I show you, you study the Thailand Industrial Standard. There is two things. One is the specification of the material that's required to pass, required to meet, or in the specification. The second one, the TAS tell you about the way to test the material. Okay, so when we test the material in the same way, that means we can compare the result from the test to each other. So it is a requirement that you're going to what, to test the material in the given in the specification. Okay, so that is your duty as the engineer, and then you can do both. Okay, you testing for acceptance, and you can testing for the the quality control. If you work for the CPAC, you do the test for the quality control. If you work for the Italian Thai and you buy the concrete from the CPAC, that you test the concrete for acceptance. Okay, and then that means steel, concrete, brick, and also material you got to check, okay, because high quality material going to be a good start for the high quality building. Okay, and that's all for today. Okay, bye bye.